Hey Travis and Jim, don't you people have other things to do in your lives? How'd you go today, Jim? I think it was you were on the bus this afternoon when I last heard from you. And Travis, of course, I ignore. Hey B-Blood. Alright, so we've got another 1398. This one's a bit dirty. And this one really has no chipmunk or anything. I do get MagSafe activity, but I don't get any chipmunk activity. So we get MagSafe. We're drawing 300. It's a bit of an odd one. 300 milliamps going nowhere. Not sure. I don't really have a particular fault nature in mind for this, so we're just gonna have to take it apart and see what we got. And I've got to try and get done before midnight, because midnight's my cut-off time. Because as much as I would like to work until the wee hours of the morning at 3 o'clock, I don't think it's overly good for my health. So I am trying to knock off at least by midnight. And hey, I just noticed there's no covering cap on that. Okay, good to note. Hey Christian, Gerhard. Hello. I'm not sure how to pronounce this, but Iftikhar? Iftikhar? I don't know. My apologies about butchering your name, sir. I was heading home from one of the 2 ongoing medical appointments a week. I suppose there is some comfort in a routine medicals. Not that you want to have them in the first place, but at least if it's routine, it's sort of part of, yeah, you're already in the system. That helps. Hey, Olison. By the way, that 165 board that I was working on earlier, I thought I had found the cause of the PCI SA fault, because there was corrosion around the speaker amplifier, and I thought SA speaker amplifier, yeah, maybe it's it. I did think it was a little bit unusual that they would have a temperature sensor on something like that. But the nature of the PCI system, which is the peripheral, I think it's peripheral environmental control interface or something like that, is that, yeah, it does work over its own bus. And so because we are getting other data values and they are all steady and working, then I know it's probably not bus related, which means the CPU and the SMC should be okay. But instead it's gonna have to be something within an individual chip that's at fault. And it may be the CPU itself, it may be a certain portion of the CPU. There's a bit of corrosion under there or something like that. So I'm just going to ultrasonic the board. I've done the best I can, and see if it continues to misbehave. Hey, g'day Phil Coder, how's it going? You keeping busy, I take it? You're always busy. You're in demand, that means you're going to be busy. I, for the first time in a long time, actually have a bunch of boxes that I have not yet opened sitting in the entrance workshop, and that kind of scares me a little bit. But I keep on pushing, because obviously some days you have very little work, and then other days you have complete and utter chaos. So it looks like we're working in the chaos realm for today. Hey Patrick, Pianov. SA system agent, part of the CPU, PCI, yeah, the PRK. SA temperature sensor going to 0 is normal. That's interesting, Pernell. Thank you for giving me that information. Maybe it's just one of those things that I've never noticed before. You know how you can look at something for ages and never notice a particular behavior? And then for some reason it catches your eye and you... Yeah, maybe it's Is it possible that it's unique to the 1.8 gigahertz 8 gig RAM version of the 165 or anything like that? I'm just genuinely asking out of curiosity because I don't seem to have noticed it in any of the other times I've used that. Unboxing stream? Very unlikely. No, these are customer machines, they're not gifts. I am waiting on my desktop CNC to arrive. That's another thing. I did thank someone for helping me find out, as in it went on discount price after I thought it had come off it, and a certain person told me it was back on discount, and I gave him thanks for that, because that saved me $150. Hey Alexandra. Alright. So I don't know, anyone want to throw some theories as to why they think we've got 250 milliamp and we do have MagSafe, so we know 342 is going to be up, SMC is likely up, but beyond that we don't have anything. It's just 230, 240 is a bit of an unusual value for these boards. Crack PCH, I hate you, I hate you. And I can tell you it's not that, because that's the PCH there and it's not cracked. You can go to hell, Travis. Okay, Pilnoff. Alright. Well, I appreciate the input because, you know, that really was bugging me. But in fairness, because it was bugging me, I found that bit of corrosion under the speaker amplifier. So I guess it was a win in the end. Coda is going to say corroded BIOS. Well, it's nice to see someone who doesn't go for the total death option. Murder, death, kill option. Okay, we got little specks of corrosion, nothing dramatic yet. By the way, people keep sending me graphics cards to fix right now. Looks like it's not really a choice for me to fix them, as in not fix them. People are just sending them. So, time to ramp up on that. I'll have to do a lot of reading, more research. Cat hair. Okay, you know, honestly, your guess is as good as anyone else's. There's a bit of green under here. Is that corrosion or is that part of the resistor? It's part of the resistor. Clearly they didn't laser cut it properly. Now, if it was booting or powering up or attempting to power up and then shutting down, I would blame the VRMs, but that it's not the situation that we're facing as yet. It may be that the VRMs still need replacing anyway, but at this point, it doesn't appear to be the primary candidate. So we do have spicks and specks of corrosion, but not quite enough yet. And there's that by that cap. Yeah, still not quite enough. Hey user. Okay, let's try the unusual side of the board, which is the top side, which funnily enough is the bottom side, really. Lots of fingerprints. I don't know how we get so many fingerprints on those shields, considering that it's installed by Apple people, and they of course would always be wearing gloves. Again, little spicks and specks of corrosion, but I mean we only do need one bit of corrosion in the inappropriate location, and that is the end of it. There's your BIOS. We're not seeing anything there, unfortunately. More cat hair. The CPU VRM should be okay, as in from liquid damage at that point. And it's a 138 board, by the way. Yeah, alrighty. This one's a bit of a curveball. So at 18,250, that's about 4.5 watts of power going into it. So if it is going into a particular single short somewhere, it will show up. If it's going into the circuit board, it's not going to. If it's going into the CPU, it will ultimately, but not directly. Now, I know people say, you should bring out the multimeter, go check the rails and stuff like that. But we're trying to be a business here, so that means we are going to bring out the gym cam and see what's hot. And I don't mean the people running around in tight shorts in the gym. I'm talking about gym hook cam, which is the infrared camera. Right, where did we put it? Like so, I know it seems like a bit of a cop-out, but realistically, I've got to get things done on time. And if this saves me 20 minutes, then I'm more than happy to use it. Now I gotta remember my controls for it. Okay, FLIR is up and running. At least with these boards, when I apply the power to it, you can see what the current is while it's doing the scanning of it. Alright, let's have a look, see if anything's getting warmer. Oh, there we go. ISL, I think that would be. No? Well, something about there, and you son of a bitches, it's a PCH. It's the goddamn PCH. Did I ever mention how much I hate you all? It's hard for me to describe how much I am disappointed by your behavior in general. I mean, honestly, who the heck did that to me? And it's getting hot all around, so it's not likely to be just a cap or something like that. And I don't really have a source of PCHs to replace this one with. It's not cracked, although what is that little dot? No, that's just a piece of junk. No, I don't think there's really much I can do at this point. I'm not going to try and take that plastic cover off. I wanted to see if there was an actual void development somewhere. Like certainly like the 165s, they'll crack or they will punch through this beige looking epoxy. But nothing of the sort here. Well, look, there is one upside to this, and that is that at least it was over and done quickly. Now I don't know, maybe there's something else that could be causing the PCH to get hot like that. Maybe it's not really a PCH failure. Maybe it just simply can't get started due to something else. Yeah, that's what I have to contemplate. Because 230 is not a massive... hey, Byron. 230 is not a massive amount of power. It's not really what you would consider a short, particularly going into a PCH. If I had to say, I might actually even think that the PCH is just getting warm by normal standards, and something else is inhibiting it. Anyone want to weigh in on that theory? It's not burning hot, Pernov. It's just, I can put my hand on it and it's warm to touch, but it's certainly not burning hot. Like I said, it's only four and a bit watts of heat going into it, but it's not in SO state, or at least, put it this way, we're not getting SO 5 VSO. So I'm not really sure. The other thing is the heat was fairly uniform across it, as opposed to being a point heat. I mean, I know the resolution of the FLIR camera, the infrared, isn't that great, but it's also not that bad either. It will determine if there is a pinpoint, and usually when you get a short in something like the PCH or the CPU, it tends to become a pinpoint source. So I'm still going to dig at this a little bit. So we're switching to resistance mode. Let's see what we got. 16 on the CPU. That's actually pretty good. Should be much the same. Yeah, 16. So if it's not that, say it's not the PCH. Yeah, that's all looking good. I'm going to test some rails, see where something might be missing. I'm just not fully convinced it's PCH. I think it's more a red herring. I think I may be wrong. I may be wasting my time. But I do want to check some rails. I'm also going to plug the chipmunk back in, just in case something jumps. Okay. Millivolts. Let's see what our PP bus actually is, as opposed to what we assume it is. 1.2 volts. Okay, there we go. See, now that's what I'm talking about. See, 1.2 volts. That's no freaking... we've got a PP bus problem here. By the way, Phil, I got to thank you. Due to the way that I didn't realize there was a you can't chat unless you subscribe option, and I found that out with your channel. And so through you, okay, our 342 is running fractionally high. Anyway, so through you, I found out I could get that feature, which has now thankfully reduced our spam levels considerably. Hey, Patrick. Squeaky. Okay, so where's our PV bus short? Can't be too severe as it's at 1.2 volts rather than 0. I suppose the easiest thing for me to do is put some current, voltage in and see what pops up. Obviously nothing more than about a volt and 3 amps. It seems to be the easiest option here rather than chasing all over the board. feel free to give your opinions, as much as I will feel free to ignore them. Yeah, because I remember seeing Phil's channel, and because I saw other people running off to it, and I thought, who is this yobbo? And I thought, I'll go sticky beak. And then when I was sticky beaking, someone said something, and I thought, oh yeah, I'll make a comment back on their comment. And then it said, you have to be subscribed in order to be able to chat. And I thought, you lousy bastard. And so I subscribed. Should measure exact resistance from ground on PV bus, see if there's a possibility of high side. I guess that's why I was going to go for very low voltage first, but yeah, we should do that too. And I know some people get a bit crazy and decide to pump 5-6 volts in. But yeah, it works really good for spammers, I'll definitely say. Since we've done that, we've had very, very few spammers come in. Alright, let's see what our PV bus resistance to ground is. So we have 50 ohms. Now if I put, I'll maybe get 120, 200 milliwatts out of that. So we're not going to get a large amount of heat, but it might be enough at least just to give us a hint. Shorted 1VOS5 high side. Let's have a look at the 1VSO5 high side. 138 board. One of the big pains with this series of boards is that between the 138, the 426, and the... crap, what's the other one? 168, is it? Anyway, between all those boards, they all seem to have a really mixed up set of values. Some parts are correct, some parts aren't. Yeah, they're sort of all mismatched all over the place. I'm going to go back to my olive theme. Let's see, 1VO5 is a 5. Sorry, I'm going to lose my microscope here. Oh, that's all PCH. Who's generating my 1VO5 on this board? Yeah, okay, we'll try the 163. I do need to migrate that information from that other board program. Hey, macro pairs. Hey Harold, welcome. Ach nee man, that's not what I was searching for. So 7600. Specifically Q7630. Okay, lo and behold, right up there by the PCH. In a very undesirable place on the board in order to be able to get it off. So what I'm going to do is check between, let's see, pin 10 and pin 9 and 10, or pin 2 and 10. Let's see, pin 10s, damn it. Okay, so the inductor. Okay, so between, it's okay, I know I'm talking to myself and you can't see what I'm doing. And basically between here and here. And we do indeed have a short. Which means that, yeah, it's probably going to be roast on toast, unfortunately. Oles, good evening. Doing repairs at the same time, I got up the pin in the middle of the night. What? That is almost too much information. Okay, we can try and remove that MOSFET. See if all of a sudden that short changes. What a nuisance for that to go pop and die. And like I said, that's in a very awkward spot to get that out. Exceptionally hard. Because you've got the soft melty plastic here, and you've got soft melty plastic here for the SSD. So this is the Wi-Fi. And you can protect to some degree. And the other thing is it's deep within there. So you've got your coil there, you've got a cap there which probably wants to pop its head as soon as you get it hot enough. And yeah, that's no easy MOSFET to get out. I might see if I can. See, I can barely even get. Yeah, I can barely get anything in there to even try and pickle it. I mean, you try to get. You could just get something down there. It won't be much of a pickling, it'll be more of a tickling. Ach nee man. Get some 250 down there to try and help it without melting things. We'll start with this side in the meantime. Like I said, we're not trying to make proper connections or anything. We're basically just trying to drop some lead solder down there to give us a chance for, once it starts reflowing, to drop the temperature a bit, that it can come off. But I don't like my chances. In fact, my chances are already zero pretty much anyway here. Especially when I don't have the filter on. put a plumber's iron on and sweat it out. Good idea. I've got the problem that the damned Wi-Fi connector decided to get friendly. This is so not going to go well. Oh well. This is going to be a slow process. Basically, we're going to try... just move things around. We're going to try and pretend we're a a hot air oven. I'm just going to try and push it closer to the extractor. Yeah, we're going to pretend we're a rework oven and just let things come up to temperature. Meanwhile, I am seriously keeping an eyeball on the plastic over here. Because even when the end pieces of the pads, even when they have melted, you've still got to get the pad that's actually underneath it all. See, they've gone and melted now. That's great, nice and easy. But the real trick is the pad that's where all the current actually goes through, and that's underneath. Yeah, that's not going anywhere yet. Probably won't for a little bit. Because most of these plastics, they will take a high ambient temperature, but what they don't handle is when you have directed heat, directed hot air blowing on them. So you can put them in a... It's like I said one of the other streams, it's like the opposite of wind chill factor. Well, it's actually the same thing as wind chill factor, except it's cooking factor. There you go, we didn't melt it. Definitely patience is the key on that one. Ceramic fiber installation. Sounds like something that would get in your lungs and cause you cancer. And the short is gone. Like I know you can get, or if you're doing forge, making a forge, you can get this fiber stuff that does an excellent job of insulating, but it also completely wrecks your lungs if it gets into... Asbestos works well too. Miles, I'm disappointed that I shocked you. We don't want too much on there. It doesn't need a lot. Just enough to make a join and that's it. The end ones are fine because they can squeeze out, but we don't really have the option to squeeze out on that when we put a new one on. Not with how everything is all jam-packed in there. We essentially just want it to sit down. So we'll get ourselves another one of these, but it's, as Pilnov mentioned earlier, it's likely stuffed. Very, very stuffed. Yeah, the blue stuff. Blue. That's only if you get it from the Blue Sky mine. And only if it's approved by Midnight Oil. For this one, it's not going to matter so much. I can just pretty much blast at this one. It'll be an interesting comparison to see how the connectors fare without the shielding and patience. But I still will have to be moderately patient to get this out. Yeah, it's not going to just come out and yeah, there you go, see it's already bobbled up. So I got a different footprint. It's not the same chip. It's not the same sort of MOSFET. I think it's like a 3767 or something like that. Yeah, that's not the same MOSFET. So it looks like we do really need to find a 138. Yep, another 3332. 138s are not exactly the most common thing I have here. I don't know if this is a 138. No, 3787. Unfortunately for me, oh wait, the next one on the next one beneath it was a 138. At Textralian. So it was interesting to see that. I mean, I sort of figured the MOSFET itself might be a different model or batch or something like that. But I gotta admit, I actually thought that they would maintain the same footprint. But clearly, that is not the case. I don't know why I'm trying to do this. Just maybe practice, who knows. Anyway, at least the good news is that I didn't just blindly take that MOSFET and slap it on, even though it probably is not going to have any effect whatsoever. Given that the PCH, as has been determined by those in the chat before I even had a chance, they already dictated that that PCH shall die. So the PCH was actually just fine, but then when everybody said it's going to be dead, it got upset and it died. So I hope you're all happy with yourselves. This is definitely a more difficult unit to remove. It's getting close. Nice, it didn't actually do any damage when I did it like that, so that's something to note. Okay, what I'm going to do here is pre-soak the board for a fair bit. This is just going to be 250. So it's not really going to do anything, although technically 250, if you wait long enough, it will make things, yeah, it will solder that. Because typically when you have if you look at parts you buy, surface mount parts, and you look at the profile, the reflow profile, you will notice that it peaks out at around about 247, 250. So if you sit here long enough with a hot air station at 250, then theoretically it should eventually reflow. The downside is probably so will everything else around it because it took so long. So what I'm trying to do here is by heat soaking the board, when it comes time to do actually get it to drop down, then I don't have to put the shield on for too long. And I may be able to do it at a slightly lower temperature, something like 360 or so. You can see that solder there is melted. Okay, we do have a slight issue here. Technical difficulties. I kind of want to sit there, but it's not going to because the MOSFET's no longer there to do it. I may be able to... It's a nay. Just... Nay. Don't mind me, I'm just talking to myself. Professional opinion and all that crap. Burning my freaking fingers off. Crap. I need my reverse tweezers. Beautiful. That's what I'm talking about. Or at least it was until it did that. Wrong end of the tweezers, Paul. Pardon the language. Good God, that's warm. Oh, maybe I should just hack at it. All this just simply to prove that the PCH is indeed very dead. And naturally that's now soldered itself. Ow! Hot things hurt the hand. Oh, it's far from perfect. Wrong way, I had to keep pushing it around because it actually hadn't sat down. It had reflowed these bits and these bits, but the pads on the underside, they were not reflown. So I had to push it around to get it to drop. Well, we don't have a short. But then the PCH is roast. Unfortunately, Miles, no, the hot air pencils don't really have the capacity, the thermal transfer capacity for these situations. Oh, g'day, Jason. Welcome back. It's one way. It's more a case of with chips like that. You sort of, you know when they're not yet floating on the... Wow, look at that. That just melted up just through proximity. Oh well. We should really take these wires off because it would be less than hilarious if after all that, say if the PCH did come back to life and I inadvertently shorted. Thank you. Thank you. Let's put a chipmunk in there. We may get SO on the chipmunk, but we're probably not going to get CPU activity. Yeah, we had a little flicker there and that was it. Certainly we're... Okay, we're up to 300 again. Yeah. It's dead. There was an infinitesimally small flicker for a moment then. A beep and then it dies. Interesting, it's actually the resistance is lower now than it was before. It's kind of comical, I think. that has shorted again. Oh, that's weird. Interesting. So how's the controller killing it then? So what's the controller doing? Is the controller pumping? Yeah, let's have a look at this. Let's have a look and see how they've arranged this. Okay, so the controller, it's got a boost converter, or flyback sort of boosty converter to give us a high gate voltage, and then for some reason it's blowing that MOSFET. Yeah. Kind of wondering how it's blowing the MOSFET just through the gate drive. Maybe because usually these have something like a VGS of around about 30 volts. And so unless this is driving, yeah, maybe with this it's generating something more than 30 volts and it's punching through and causing that to bridge. Oh, it's interesting. Oh well, we could try swap that again. Way to waste my time. Oh wait, is this one of those GA... Oh, this is a GAV controller? Okay, these ones are the actual GAVs, they're not GAY ones. But even still. It looks like my focus is out at the moment with my vision. And I've got 30 minutes. So 30 minutes, we'll give it another shot, and that's about it. But yeah, I'd like to know what you think is the mechanism by which it's destroying the MOSFETs each time. So the only thing I can really think of is that it's generating a gate voltage in excess of 30 volts. I don't know what the exact spec is for that particular MOSFET, but yeah, like I said, usually VGS is around about 30 volts. Some of them are 40, but maybe this one's only 20 volts, in which case it's probably possible to damage it. I mean, I can expect a controller to keep the gate drive on permanently. Mind you, that would actually be pretty hard with that, because you're trying to get a N-channel MOSFET to open up like that because it's on the high side. You have to essentially keep pumping. I suppose it doesn't need that much, I guess. Yeah, that is the nice thing about MOSFETs, is you need very little gate charge and it doesn't bleed away too quickly. It's just a bit of a curiosity for me. Not necessarily gate over voltage, ringing, slow switching, or overlap. High side, low side. I mean, maybe a direct short to ground, but even still, I don't know. I guess it depends on the internal the nature of the MOSFET itself, but no. Oh well. Let's just try it again. Even if we don't achieve anything, we might learn something. Well, I did test around it before, and when I removed that MOSFET, everything came up as it should. You're right, Bjornov. Another good reason not to be on chat while working on machines is you forget stupid stuff. Well, I shouldn't say you forget stupid stuff, you forget important stuff. It's a bit like when you have the ISL, you get a short on PP bus. It's not unusual to also replace the ISL at the same time. Hey, g'day ITC. See if that one pin on the GAV chip is just not quite soldered there. Just apply a bit of saw action. It's better. I'm going to have to use the part search feature on Flexboard View and go find another one of those MOSFETs, because I don't know if I've got another 138 board sufficiently handy on hand. You watch, it's probably something exclusive to the 138, or I should say unique to the 138. On the upside, this should come up a little bit easier than the original one, simply because of the fact that we do have leaded solder, and also the board is already warmed up a little bit. It's got sort of 20 degrees extra temperature. There we go. Yep, see? Easy. Too much. Those all look about right to me. Schematics. So this is it's one of those things. Search, find a part, Control V, search. Oh, I don't like the fact that we haven't had any hits yet. Well, this really is going to be a one board chip. Oh, that's going to suck. Lo and behold, 138 has it. Shock horror. Oh, 163 has it as well, but then again, we don't know if that's... Yep, so 426, 163, 138 may have it. That's alright. Trying to dig through my boards. 3332, definitely not you. A board that I cannot read because I am blind and old. 3787. Triple 32. 3787. $426. I'm shocked. 3662. 3787. 3662. Yeah. For some reason I have 1502 boards in here and they shouldn't be, but oh well. Loud noises. A 138. I actually did have another 138. I'm surprised as much as anyone else. Yeah, waiting on parts is a very frustrating thing, and it's the only one of the big reasons why I forever am having to expand this workshop, because I just simply, have to keep holding more and more laptops or more and more jobs, and they fill up the existing slots, of course. And when those slots get filled, I still have obviously other jobs coming in that I need to attend to. And you can't very well attend to jobs if you don't have space for them. Hey Joshua, welcome. Going to ramp up the speed of the air filter. Well, one thing's for sure is we've certainly learned how to get that part out of there. Hey, 555. Just going to put you there. Check our continuities. So 550 there. No short on that gate. Yeah, that was just a capacitance on the rail. Anyone transplant the battery connector from 3430? Yes, Jason, I have done that a few times. You can do it from above. I'll tell you what, I'll do one after this. Just that 3437? You're talking about, yeah, Oh wait, 34th, 34, 37. Yeah, you're talking about A1466 job. Jason, as long as it's working. Once again, not perfect, but not the worst either. Just putting it on the cooling rack. 3437 battery connector. Yeah, I mean, some people will take it from the bottom, but I don't like doing that because usually it tends to cook some parts around here. I think the trickiest thing about this connector is the fact that the pins do go all the way up to around about here, so it's a bit of a patience pusher. Alright, let's see how long the blink lasts this time. Probably not. Interesting, we don't have a 5-volt output. So we've got power showing, but it's not good. It's not a good 5 volts, and we lost power. And something's on fire. Something's smoked. I don't suppose anybody saw or if anything lit up like a... I definitely smelled something burning. And it wasn't this, that was already done like that. Yeah, something definitely burned. Hey, Tezza, it could be the MOSFET again. We'll see. And the answer is no. MOSFET did not die this time. No, definitely was the distinct smell of... I'm pretty sure it was a cap. Then again, I'm questioning myself now. It was running for a bit, and then it dropped its guts. Could be anywhere on this board. was interesting that I wasn't getting 5 volts, so something was definitely hauling down PP, not PP bus, but is that corrosion on there? There's bloody corrosion on there anyway. Yeah, look at that. That's on the CD3211. That's why you got to pick up the boards at an angle. Thanks, Greg. I mean, it wasn't violent. Yeah, normally you can hear something go crack. I didn't hear any crack noises. I mean, as deaf as I am, I can usually hear that signature crack noise. It could have been the PCH just yielding. I think it was the PCH actually. I think it is now correct. I'll just have a look. I'll wash that down. I don't know if thermal cam's going to give us anything. I'll try. Oh no, PCH is fine. At least. I think so. That's not a crack, is it? Is it a scratch or a crack? Looks more scratchy than cracky. I'll just see if it draws anything, repeats the behavior, whether it's completely shot through now. Yeah, it's gone back. Yeah, it's not holding, and we're back to 278. I have a feeling it was the PCH just yielding. I'll check the caps. Nothing. 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 They're all reading okay. And basically we are back to... Is this shorted again or... No, we're not shorted and we're not dying. Okay, user, thanks. I don't know what to look for at this point. I'll power it up and check PP bus voltage and things like that, but I think we're pretty much down the gurgler. It's a good time waster at this point. And it would appear that my... Yep, looks like we've lost USB. Okay, let's go for DC voltage. Hey Nate. Let's see, it momentarily pops up and then fades away to oblivion. 3.2 volts now, yeah. Nah, this is a dead PCH anyway, so whatever went through this, it's gone. Which is unfortunate. But it is gone, and unfortunate. I say it's unfortunate because that's another frickin' hour and a half of my life. I should have just gone with the original thing, but you know, I had that moment of hope thinking I can save it, and I was an idiot and actually went with it. Personally, I'm blaming Pionov on that. I should have been happy with just seeing that the PCH was getting hot relative to everything else and left it at that. By the way, Phil, how the hell do I contact you outside of your chat or you being in this chat? Because quite frankly, I can't find an email address on your side. I can't find a messaging number. I don't know what your Discord is. I don't know where the hell you are, Phil. You're just like this mystery man that no one can get a hold of. Unfortunately, this is a customer machine, so I can't do anything untoward to it. As much as it would be fun. Maybe, Phil, you can email me instead, because at least all my details are out there. And then at least I've got your contact and I can go from there. I'm more trying to aim at the base here and get it to wick that heat through. Probably the more sensible thing to do would just be buy replacement connectors. Here it comes. Jason, that's at 470 and 90% air. So it's actually quite hot. If I got too close to it, it would very rapidly melt that. But yeah, the problem is just the fact that these connectors go in quite deep. So you really need the board to warm up. Like I said, the other way is people just cook this backside here. If it's just a donor board, just cook the backside and it will come off a lot quicker and easier. But if you don't have a choice and you have to go in from the top, then just, what was that, 2 minutes? So yeah, it takes a while. Oh yeah, I've got a new battery connector. Alright then, well that's it. Another completely crappy night where nothing got fixed. That's 2 for today. I mean, yeah, okay, that one, what is it, 1466, I will wash that board tomorrow and it's probably going to be okay. Anyway, hopefully it should be good. But that's it for tonight. I'm off to go and play a little bit of 7 Days, eat some food, have a shower, get prepared for bed, and tomorrow tackle it all again. And wow, it's going to be Thursday tomorrow. Jeez, the weeks go very quick around here because Monday's always well, not always, but Monday's often a catch-up day. Like everybody's getting in touch with everybody and like, oh, how's this job going? Or and then you got to order parts and things like things that you found over the weekend. Tuesday is a busy day because most of the time that's when shipment of machines and parts come and arrived, and then also it's rubbish night. So I know it sounds strange, but for some reason, because it's rubbish night, when you put the rubbish out, then it almost starts to be Wednesday. Wednesday turns up, it goes in a hurry too, and then you get to Wednesday night and it's like, crikey, it's Thursday tomorrow, and then before you know it, Thursday and Friday are done, you're back to the weekend. So yeah, it goes the same as everybody else, but the way it happens over here, it seems like the weeks really do just zip past very quickly. Oh, we've got Anzac Day on 25th. Yeah, that's the other thing. Let's see, Phil, invite sent on Discord. Okay, thanks, Jim. I will deal with that. Thank you, Phil. I will drop in and say hello just now before I go off to 7 Days to Die. I'm out of here. You all take care. Thanks for being here. Thanks for putting up with my crappy jobs at the moment tonight. Hopefully we can have a few more exhilarating successes over the next couple of days. But that's the way this business goes, as with most repair industries. In the meantime, you take care. Catch us later. Have a good one.